Hey everyone, welcome back to my channel. Today we're diving into Azure Kubernetes Service, AKS, Microsoft's managed Kubernetes solution that makes deploying and scaling containerized applications a breeze. Whether you're a DevOps engineer, a cloud enthusiast, or just getting started with Kubernetes, this tutorial will walk you through setting up an AKS cluster, deploying an application, and scaling it effortlessly. So, let's get started.
Before we jump into the hands-on part, let's quickly check our agenda. What is Azure Kubernetes Service? What is the core concepts for Azure Kubernetes Service? What is the deployment strategies? How to scale and manage Azure Kubernetes Service?
Azure Kubernetes Service, AKS, is a managed container orchestration service provided by Microsoft Azure that simplifies deploying, managing, and scaling containerized applications using Kubernetes. It eliminates the complexity of managing the Kubernetes control plane by handling critical tasks like health monitoring and maintenance automatically. What are the benefits of using AKS? Reduced operational overhead. Azure handles Kubernetes management tasks. Cost efficiency. Pay only for the worker nodes, agent nodes you use. Enterprise-grade security. Built on Azure secure infrastructure. Hybrid capabilities. Integration with Azure Arc for hybrid deployments. Extensive ecosystem. Access to Azure services like Cosmos DB, Azure SQL, and more. AKS provides a balance between Kubernetes flexibility and managed service convenience, making it an excellent choice for organizations looking to run containerized applications in the cloud without the operational burden of managing Kubernetes infrastructure. What are the core concepts of AKS? Cluster, a set of nodes, VMs, that run containerized applications managed by Kubernetes. Worker nodes, a VM worker machine that runs containerized workloads. Node pools, groups of nodes with the same configuration, CPU, memory, OS. Pods, the smallest deployable unit in Kubernetes running one or more containers. Deployment, manages the lifecycle of pods, ensuring the desired number of replicas are running. Service, an abstraction to expose pods as network services, cluster IP, node port, load balancer. Namespace, a logical partition within a cluster to isolate resources, dev, prod. Control plane, handles scheduling, scaling, and maintaining cluster health. Users don't manage this. Ingress controller, Nginx, Azure Application Gateway, manages external access to services, HTTP, HTTPS routing. AKS deployment strategies. When deploying applications to Azure Kubernetes Service, AKS, there are several strategies you can use to manage updates and rollouts. Here are the most common deployment strategies. 1. Rolling update, default in Kubernetes. Gradually replaces old pods with new ones. No downtime during deployment. Kubernetes default strategy. Controlled by max surge and max unavailable parameters. 2. Blue-green deployment. Maintains two identical production environments, blue and green. Only one environment serves live traffic at a time. Switch traffic all at once when new version is verified. Requires additional resources as both environments run simultaneously. Implementation typically uses service selector changes, ingress controller updates, traffic manager configurations. 3. Canary deployment. Gradually rolls out changes to a small subset of users. Allows testing in production with minimal risk. Can monitor metrics before full rollout. Implemented using service mesh like Istio, ingress controllers with traffic splitting, feature flags. 4. A/B testing. Similar to Canary, but based on request parameters. Routes specific users to different versions. Useful for testing UI changes or business logic. Typically implemented with service mesh, ingress controllers, application-level routing. Now that you know why AKS is awesome, let's create our first cluster. Sign in to the Azure portal. Create a resource and then select Containers category on the left. As you can see, there are quite a few services under containers category that Microsoft offers, apart from many more from marketplace offerings. Now, under Azure Kubernetes Service, I will click Create a new resource group. I will name it RG1. Next, I will name our Kubernetes cluster as AKS1. I will then change the region to Southeast Asia, that is, Singapore. Since this is not a business-critical app, and because I want to save some money, I will uncheck all availability zones. When you select more than one, Azure will spread the nodes in the node pool across availability zones, providing higher availability. You should of course do this in your production environment. One thing to note on ASs is that not all regions has availability zones. For example, if I were to select Australia Southeast, there are no ASs. Alright, let's go back to Australia Southeast and uncheck all availability zones. I will leave the default version of AKS, which as you can see is the mid version in the list. The Kubernetes community releases minor versions roughly every 3 months. AKS follows 12 months of support for a general availability CTAT, that is, version. So version 1.24, which went GA in July 2022, will be supported for 1 year from that date. Microsoft does provide a pathway to upgrade deployed AKS clusters. I will leave the default node size to DS2 v2. In Module 2, I talked about various VM sizes available in Azure. This one has 2 vCPUs and 7 GB of memory. Let's set the node count to 1. This will give me an opportunity to show you how to scale it up later. Click Next. Since we have set the node count to 1, node pools show that as the maximum. That is, minimum is set to 1 and maximum is also set to 1. If I were to go back and change the max to 5 and click Next, you will see that reflected here. Also note that the max spots per node is set to 110. If you need to add more than 110 pots, you will need to add more nodes. This, by the way, has nothing to do with VM size. You can select a VM with 32-core CPU and 128 GB of memory, but the port-to-node ratio is between 30 to 250, which can be configured if you click on the agent pool. Let's set this to 30 and click Update and then Next. In the Authentication and Authorization blade, you have 3 options to select from. We will leave the default here and move to the next scene. I will discuss this option in some detail in the next module. In the networking option, select Azure CLI. Since I do not have any existing virtual networks, I will let Azure create one for me. Do not worry about what these options mean. The network configuration and network policy are important settings, and I will discuss them in the next module. For now, let's click Next. We will take this opportunity to create a Azure Container Registry. Container Registry is a managed service that is based on open-source Docker Registry. This can help you store our container images, like the one we created in the previous module, securely and privately. I will give it a name, use the same resource group and region. I will choose a basic skill. SKUs in Container Registry is about higher performance and ability to replicate across the globe. Since we do not need all the jazz, let's select Basic and click OK. Let's enable container locks and let the logs go to this new log analytics workspace that Azure is creating for us. And yes, we will come back to monitoring later. Click Next to go to Advanced Plate. The Infrastructure Resource Group is where all the info related to AKS, like networks, VMs, etc., are created. Microsoft recommends to leave the defaults, but in your production environments, you can change it if the naming policy has required you to. We will click Next and leave the tags blank for now. If you have used any cloud platform before, you know what tags are. If not, you can ignore these for now. In the next screen, Azure runs a quick validation to see if all the required options are filled and if we can continue with the deployment. Once the validation is complete, let's click Create.
Now we had deployed an AKS cluster along with prerequisites like resource group, virtual network. In this demo, we will connect to that cluster with CLI. There are a few ways to connect to our AKS cluster via CLI. You can use the Azure Cloud Shell to do that without the need to deploy anything on your computer. All the dependencies like Azure CLI and Azure PowerShell modules are pre-installed in that. You can also use PowerShell on Windows or Terminal on your Mac or Linux machines to connect to Azure. I will use PowerShell on my Windows machine to connect the process. I have logged on to Azure CLI via AZ login command to connect to our AKS cluster. I will need to get the cluster credentials. Before we do that, let me run the AZ account to show the subscription we are connected to. This is important to validate if you have more than one subscription in your tenancy. Now, most CLI commands require you to pass the resource group parameter, and I am lazy, so I will set the default to our AKS resource group by typing azconfigure default group and set it to the resource group we created previously. Now I will run AKS get credentials command along with the AKS cluster name. This will download the credentials and merge it into our current user context. Now that we are connected to our AKS cluster with correct credentials, let's validate if kubectl can access the cluster. Running kubectl config current-context will display the current context, that is the AKS cluster we connected to so far. So good. Now we will run some common kubectl commands. Do not worry if you do not know all of these commands. As you start to use these commands, you will know what they do and what parameters they require. Running kubectl get nodes will show all the nodes that our cluster have. If you remember, we had set the minimum and maximum to one node, and that is what is showing here. If you open the Azure portal, this is the same name of a virtual machine scale set computer name.
And that's it. You've just deployed AKS. Jeez. If you found this helpful, smash the like button, subscribe for more cloud tutorials, and drop a comment if you'd like a deep dive into AKS networking or monitoring. Thanks for watching, and I'll see you in the next one. Happy cloud computing!